Hey guys, how you all doing today? And it's Jalaj Aura here again, back with another video from BHM at GCSE Chem, and today we're doing C2.3, which is Group 1, the alkali metals. And this is the book that I'm using, so I always show you this, the GCSE AQA Caboodle revision guide, and yep, and so as I said, I'm doing this section now, C2.3, which is on Group 1, the alkali metals. So I think, I'm not going to make much, make the introduction too long. In fact, I think there's nothing much else to say, other than also that, I couldn't upload, I didn't have time yesterday to actually, put C2.2 on my website. If you don't know what I'm talking about, basically I have a website that I've recently made, and I'm, on GCSE Chemistry, BHM at GCSE Chem, where I'm putting all these videos. Yesterday I wasn't able to kind of put C2.2, so I'll be recording this C2.3, and then I'll be putting both C2.2 and C2.3 on the website. Hopefully I'll be able to do that today. So it should be there by today, if not tomorrow, but hopefully I'll try to do it today. But yeah, without further ado, let's get into the video. So, as I said, today we're doing C2.3, Group 1, the alkali metals. And they're very important to learn about, very important to know about. So the Group 1 elements are called the alkali metals. They are very reactive metals. And by the way, before we start as well, I'm using my, a MacBook today to record the video. So yeah, not using the usual laptop, but from tomorrow I'll be using that again. And as you can see, again, I'm back in my room as well. Not doing it in the lounge today because, again, my family are watching television downstairs. Didn't want to disturb them, so yeah, I thought I'd just come upstairs and make the video. So yeah, just needed to tell you that. And I think I recently made a video in my room as well again. So again, I'm making the video here. So yeah, let's start properly now. So the Group 1 elements are called alkali metals. So the alkali metals, they are very reactive metals. Yeah, that's important to know. They're very reactive metals. Now, alkali metals are soft solids at room temperature with low melting and boiling points that decrease going down the group. They have low densities, so lithium, sodium, and potassium float on water. So that's very important. You need to know these properties. Basically, we're learning about Group 1 here, alkali metals. They're soft solids, they're solids, basically. They're soft solids at room temperature with low melting and boiling points. They have low melting and boiling points. So basically, as you go down the group, the boiling point, the melting point and the boiling point, they decrease. Melting points and boiling points decrease going down the group. You need to know that as well. And they have low densities, and lithium, sodium, and potassium can float on water. So that's important. And basically, before we get into the first question, hopefully you can see this is just the Group 1 elements, the alkali metals, lithium. Oh wait, why am I on francium when I'm saying lithium when I'm on francium? Sorry, lithium, sodium, potassium, rubidium, cesium, and francium. There we go. So that's just a part of the table, which is the Group 1 section basically, which is lithium, sodium, potassium, rubidium, cesium, and francium. And so these are the alkali metals, Group 1. Yeah. Now here's a question: why are the alkali metals stored in oil? We haven't really covered this in what we've read so far basically today, but it's basically to stop or prevent any reaction with air. So that's basically the reason, and that's just something to learn. I'll just make sure again. I've said that I will be checking just to make sure I give you the exact answer. Chapter 1 was quite easy, one word answers or something, so there wasn't really any doubt there. But now from now on I'm gonna definitely, or from the start of chapter 2, as I said, I will be going through the answers as well. So yeah, to prevent reaction with air, that's what I said. So that's just something you need to know. Why they're stored in oil. It doesn't come up a lot, but it's still something to be, to be wary of and to kind of know, and because it could come up. If it's in this book, it definitely could come up as a question. And this is one thing I think that many students actually overlook, these kind of little details. But what you noticed, you might learn the really hard stuff, and really just because you're learning so much stuff, you know, in the you can just forget to revise the easy stuff. And not that I'm not saying it's easy. This is not that hard. Let's be honest. Like, you know, all you need to learn is because to prevent any reaction with air. That's the reason why they store the alkali metals in water. That's the reason. But it's this small details that can actually, you know, cause students to actually lose more marks than actually the bigger questions sometimes. And that's, you know, it's annoying sometimes when you find out you lost 1 mark just because you maybe forgot something, you know, or made a silly mistake. But basically, I'm not trying to go off on a tangent here. I'm just trying to say that, you know, make sure to learn basically everything in this book. And also I'd refer to the student book for each of these sections, because that gives you the kind of the whole kind of what it is. Basically, it tells you everything. Was this just a basic idea? And this is only, you know, good when you've actually done the content, as I've mentioned previously in previous videos. So now we're going to go on to, they react with, so these are the group 1 elements, the alkali metals. They react with oxygen in the air. A layer of oxide forms on the surface of the metal. For example, sodium plus oxygen gives you sodium oxide. So that's just reaction with oxygen. Reaction of alkali metals with oxygen. For example, sodium plus oxygen gives you sodium oxide. So they react quickly with oxygen in the air. A layer of oxygen forms on the surface of the metal. Yeah. So when they react with oxygen, a layer of oxide basically forms on the surface of the metal. That's not, you know, very important detail, but just still remember it. Sodium plus oxygen gives you sodium oxide. Here's the balanced equation. Sorry, where am I going? Wait, sorry. Yeah, here's the balanced equation, isn't it? Yeah, here. So hopefully you can see that. So let me just read that out. It's 4Na plus O2 gives 2Na2O with the state symbols. Sodium's obviously a solid. All alkali metals, as we said, are solid. Oxygen's a gas. Sodium oxide is also solid. So hopefully you can see that there. Hopefully, just to make sure I've shown you the right one, it is, yeah, it's definitely this one I'm talking about, yeah. Sodium plus oxygen gives you sodium oxide. So 4Na plus O2 gives you 2Na2O. Or 2Na. 2Na2O, yeah. That's fine. So remember, let's just remember 4Na plus O2 gives you 2Na2O. Yeah. Now they react with water to produce hydrogen gas and metal hydroxide. That is an alkali. So sodium plus water, you form sodium hydroxide, and you also form hydrogen gas because obviously it's an alkali plus water. You get sodium hydroxide and hydrogen. And again, I don't need to really show you the equation here because you know, it should be able to balance it out. We've gone through balancing equations before, so that should be fine, hopefully. Now the metal hydroxides are all soluble in water. Yeah, metal hydroxides are soluble in water. Now they form a colorless solution with a high pH. So because they're alkali, they have a high pH, they're colorless solution, and a universal indicator turns purple. The reason why that is because obviously they're alkali solutions, and that's why they have a high pH, because we're going to get to pH basically, but anything above a pH of 7, you know, we're going to get to pH, I believe it's in chapter 5 or something. But yeah, so anything, I'll just give you a brief overview. Anything from 0 to 6 is acidic. Anything, well, 7 is completely neutral, and then 7 to 14 is alkali. So that's basically how it goes. Just giving a very, very brief kind of, you know, overview of that. But we're going to go into more detail, obviously, when we get to that chapter or that section as well. But yeah, you need to know that high pH because of the, you know, they're alkalis. They're going to obviously have a high pH because from between 7 and 14, and that because it's purple, they're likely to have something. It's likely to be very strongly alkali, so alkaline. So it'd probably be between, you know, I'd say 12 to 14 or 11 to 14. Very, very high pH, strongly alkaline. Now we're on the fact that The metal hydroxides are all soluble in water. They form colourless solutions. High pH, universal indicator turns purple. I said that. Now, why are the elements in group 1 called alkali metals? Well, we've gone through this. It's because when they react with water, they form they form the hydroxides, which obviously have a high pH and are alkaline solutions. They form alkaline solutions, the hydroxides. So that should be the answer. Obviously, yeah, they react with water to produce alkalis, or the hydroxides are alkaline, or alkali. Yeah, that's fine. Or alkalis. Yeah, the hydroxides are alkalis. They produce alkalis. You can say basically any of that, and you'd get the mark. Say both of them. Actually, I think is better. But yeah, the alkali metals. Sorry, the alkali metals. So we've done that. And we're moving on. The alkali metal atoms all have 1 electron in their highest occupied energy level, because obviously they're in group 1. We've seen that rule again. The group number means corresponds to the number of electrons in the outer shell. They lose this electron in the reactions in reactions to form ionic compounds in which they have a single positive charge, for example Na+. Basically, we're going to get onto losing and gaining electrons to forming ions, ionic bonding, stuff like that. We're going to get to that. Ionic compounds. We're going to get to that later, but basically what you need to know is because they have 1 electron in their outer shell, the group 1 elements, it means that if they want to be stable, they're going to have to lose that outer electron so that they have a full stable configuration like a noble gas, and therefore they're going to form a 1+ ion, for example Na+ for sodium, when it loses an electron, because it has 1 electron in its outer shell. So hopefully that makes sense. Then they react with halogens, group 7, to form salts that are white or colourless crystals. So just remember, when they react with halogens, which are obviously group 7, so this is talking about group 1 elements reacting with, so the group 1 alkali metals obviously react in group 7 elements to form, or halogens to form, salts that are white or colourless crystals. They form white or colourless crystals. And for example, sodium plus chlorine gives you sodium chloride. Not going to show you the balanced equation. I'm pretty sure you can do it. I don't think I need to go over that. Just Na plus Cl2 gives you NaCl, and then you can pretty much balance it using what we've done before. So yeah, so compounds of alkali metals dissolve in water, forming solutions that are usually colourless. So, but when alkali metals, the compounds, when they dissolve in water, they can form solutions that are colourless. So that's not really that important, but just remember, I guess that alkali metals, when they dissolve in water, they form colourless solutions. I think just remember that. It's not. I don't think it's going to be asked in the exam too much, but it's a good idea to remember it still. Now, going down group 1, the reactivity of alkali metals increases. Now we're going to go on to why that increases, explaining trends later on. I think it's in C2.5, but at the moment just know that, or you probably already know maybe why this trend is that, why when you go down the group the reactivity increases, but the reactivity of alkali metals increases. But we're going to go into that in C2.5, so basically on Wednesday. So till then, just remember that it increases, the reactivity increases as you go down the group. Now, name and give, this is the third question, name and give the formula of the compound formed when potassium reacts with bromine. Well, that's potassium bromide, and the formula, because it said give the formula as well, it's KBr. Right, now on the up, it says, to achieve the highest grades, students, or you should be able to explain the trends in reactivity in the main groups in the periodic table in terms of electronic structure. And again, we're looking at that on Wednesday when we do C2.5. So you might already know this stuff. What I'm saying that we're going to look at in C2.5. But if you're following this, just now, we're going to look at this in C2.5. Basically, we're going to explore why this happens. Why does the reactivity increase down the group for group 1 alkali metals? And also for group 7, which actually decreases down the group, but more on that later in the later videos, by the way. Keywords in this section are alkali metals and universal indicator. And here's a picture of potassium reacting with water, and this picture is just showing you, a very vigorous reaction. Just showing you that group 1 metals react vigorously with water, basically. That's why there's some kind of that picture's therefore there. Yeah. Now key points, just to end, just before we end. The elements in group 1 of the periodic table are called the alkali metals. Yeah, we know that. Now the melting and boiling points decrease going down the group. I think that's a very important point actually, just to remember. I'm pretty sure you don't need to know why they decrease down the group. I believe that's A-level. Is that even? We don't even learn that in A-level, do we? Or whatever. Maybe we do, I'm not sure. But yeah, we do. I don't know. Whatever. Basically, you don't need to know that for GCSE. Why they actually, why the melting point and boiling points decrease, melting points and boiling points decrease down the group. You don't need to know that. You just need to know that they do decrease, but you don't need to know why they decrease. I'm pretty sure you don't need to know, but check me on that. Still, I think you should just check just to make sure. Now the metals all react with water to produce hydrogen and an alkali solution containing the metal hydroxide. For example, sodium plus water gives you sodium hydroxide plus hydrogen. So we know that. They form positive ions with a charge of 1+ in the reactions. In reactions to make ionic compounds, their compounds are usually white or colorless crystals. Remember that as well. That dissolve in water, producing colorless solutions. They can produce colorless solutions. And the compounds are usually white or colorless crystals, and then when they dissolve in water, they produce colorless solutions. And finally, before we end, the reactivity of the alkali metals increases going down the group. And again, but you do need to know. Sorry, this one you do need to know why it does increase down the group, and that we will be going through in section C2.5, explaining trends. So that's the end for today's video. That's the end of the video. Or that's the end of the teaching, the reviewing the basics basically of C2.3 Group 1, the alkali metals, and tomorrow we'll be going on to C2.4, which is Group 7, the halogens, however you say it. I think I normally say the halogens, but yeah. Hopefully this video was very helpful, and yeah, make sure to share, like, and subscribe, and turn the notification bell on so you're notified when I upload new videos that you can watch. Yeah, and I said I would go through the question quickly just to make sure that I was right for C for the last question, question 2.3, question 3 on section 3.2. What am I saying? Question 3 on section C 2.3, and it should be potassium bromide KBr. Yes, it is. So there it is, guys. I'm going to end the video here, and I'll see you tomorrow for the next video on C2.4 on the next section. Thank you very much, guys. Bye.